Hello my friend, welcome back to the Sleepy Professor channel. I'm glad to see you again. Tonight we're going to embark on a gentle journey through the silvery world of the moon. There's something deeply calming about the moon, isn't there? The way it glows, soft and distant, watching over us. The way it changes, growing and shrinking with patient rhythm. The way it just exists, constant and mysterious, asking nothing of us but offering everything. For the next little while, just relax. Settle into your pillows, let your breathing slow, and let me tell you some wonderful things about this remarkable companion that has watched over Earth for billions upon billions of years. Close your eyes if you'd like. Get comfortable. There's nowhere you need to be. Nothing you need to do, just listen, and let these lunar stories carry you gently towards sleep. Let's start with something that sounds almost magical, something that seems impossible. The moon is slowly drifting away from us. Every single year, our beautiful companion in the sky moves about 3.8 centimeters farther from Earth. I know that sounds like such a tiny amount, doesn't it? Just a little more than an inch. But imagine that happening year after year, century after century, millennium after millennium. When the dinosaurs walked the Earth, the moon was much closer than it is now, maybe 20,000 kilometers closer. The days were shorter then too, just 23 hours instead of 24, because the moon's gravity affects how fast our planet spins. It's a slow dance, this relationship between Earth and Moon, a waltz that's been going on for 4.5 billion years. You know, there's something soothing about knowing that this drifting will continue long after we're gone, that the moon will keep slowly spiraling outward for millions of years to come. It's not something we need to worry about. In about 50 billion years, the moon would settle into a stable orbit, but our sun will have long since expanded into a red giant by then. For now, for our lifetimes and countless lifetimes to come, the moon will still be there, beautiful and bright, just slightly farther away than it was yesterday. Speaking of the moon's distance, do you know how far away it actually is right now? On average, the moon sits about 384,400 kilometers from Earth. That's roughly 238,855 miles if you prefer. But here's what makes this distance feel almost comprehensible. If you could drive a car to the moon at highway speeds, going about 100 kilometers per hour without ever stopping, it would take you about 160 days to get there. Just over 5 months of driving through space. Of course, you can't drive through space and there's no road to the moon, but imagining it that way somehow makes the distance feel real, doesn't it? Not impossibly far, just very, very far. The astronauts who actually went to the moon took about 3 days to make the journey. 3 days of floating through the darkness of space, watching Earth grow smaller behind them, and the moon grow larger ahead. Can you imagine what that must have felt like? The silence, the vastness, the slow realization that you're traveling farther from home than any human being had ever gone before. Commander Jim Lovell, who flew to the moon twice, once said that when you're out there, you can cover the entire Earth with your thumb. Everything you've ever known, everyone you've ever loved, all of human history hidden behind your thumb. It's a humbling thought, one that might help put our daily worries into perspective as we drift towards sleep. Let me tell you about the moon's face, the one we see every night. You've probably heard that we always see the same side of the moon, haven't you? This is called tidal locking, and it happened over millions of years. The Earth's gravity pulled on the moon, slowing its rotation until eventually the moon rotated at exactly the same rate as it orbited Earth. One rotation, one orbit, both taking about 27.3 days. So the same lunar face is always pointed toward us, like a friend who never looks away. The far side of the moon, which people sometimes mistakenly call the dark side, isn't actually dark at all. It receives just as much sunlight as the side we see. We just never get to see it from Earth. The first humans to see the far side of the moon were the astronauts on Apollo 8. In December of 1968. They orbited the moon on Christmas Eve, and they looked down on a landscape no human eye had ever seen before. The far side looks quite different from the near side. It's much more heavily cratered, with fewer of the dark, smooth plains we call Maria. Scientists think this is because the crust is thicker on the far side, so ancient lava flows couldn't break through as easily to create those smooth areas. There's something almost eerie about knowing there's an entire hemisphere of the moon that remained hidden from humanity for all of history until just a few decades ago. All those poets writing about the moon, all those lovers gazing at it, all those scientists studying it, and none of them could ever see half of it. It was there all along, of course, patient and unchanging. The moon has mountains too, did you know that? Some of them are quite tall. The highest peak on the moon is called Mons Huygens, and it rises about 4,700 meters above the surrounding terrain. That's a little over half the height of Mount Everest. But remember, the moon is much smaller than Earth, so proportionally these are impressive mountains indeed. Unlike Earth's mountains, which are worn down over time by wind and rain and ice, the moon's mountains stay sharp and dramatic. They were formed billions of years ago, mostly by the massive impacts that shaped the moon's surface, and they've remained essentially unchanged ever since. The edges are crisp, the slopes are steep, and if you were standing in the shadow of one of these peaks, you'd see one of the most dramatic contrasts imaginable. Pure black shadow on one side, brilliant sunlight on the other, with no atmosphere to soften the transition. There's a mountain range on the moon called the Montes Apenninus, named after the Apennine Mountains in Italy. This lunar mountain range stretches for about 600 kilometers along the southeastern edge of Mare Imbrium, one of those ancient lava seas I mentioned. Some of the peaks in this range are 5 kilometers high. The Apollo 15 astronauts landed near these mountains in 1971, and they spent 3 days exploring the area with their lunar rover. Imagine driving the electric car across the moon, bouncing along in 1/6 gravity, with mountains rising up beside you and Earth hanging in the sky above. The astronaut David Scott said that being on the moon felt like being inside a geology textbook. Every rock told a story billions of years old, and they were the first people in history who could read those stories firsthand. Let me tell you about the moon's craters now, because they're one of the most distinctive features of the lunar landscape. The moon is absolutely covered with craters, from tiny pits smaller than your hand to enormous basins hundreds of kilometers across. The largest crater on the near side of the moon is called Bailey, and it's about 300 kilometers in diameter. The largest known impact basin on the moon is the South Pole Aitken Basin on the far side, which is about 2,500 kilometers across and 12 kilometers deep. That's one of the largest impact craters in the entire solar system. To put that in perspective, if this crater were on Earth, it would stretch from New York to Denver, and it's deep enough that if you stacked Mount Everest at the bottom, there would still be 3 kilometers to go before you reach the rim. Every single one of these craters tells a story of violence, of rocks hurtling through space and slamming into the moon with incredible force. But that violence happened so long ago, billions of years in the past, and now these craters just sit there peacefully, filled with silence and shadows. Some of the craters near the moon's poles are always in shadow, never touched by sunlight. The temperature in these permanently shadowed craters can drop to minus 240 degrees Celsius, making them some of the coldest places in the solar system. And in these frigid, dark places, scientists have found something remarkable. Ice, frozen water, sitting in the shadows, perhaps delivered by comets billions of years ago, preserved in the eternal cold. Future astronauts might use this ice, melting it for drinking water or breaking it down into hydrogen and oxygen for rocket fuel. Ancient ice from the beginning of the solar system, waiting patiently to help humans explore the cosmos. There's something poetic about that, don't you think? The moon doesn't have weather the way we do on Earth. There's no wind, no rain, no clouds, no storms. The sky is always black, even during the lunar day, because there's no atmosphere to scatter sunlight and make it blue. A footprint left by an astronaut on the moon could potentially last for millions of years, undisturbed by wind or rain. The only things that might eventually erase it are moonquakes, the very slow rain of micrometeorites that constantly pelts the lunar surface, or another astronaut happening to step in the same spot. The 12 astronauts who walked on the moon between 1969 and 1972 left behind footprints, equipment, flags, and various other traces of their presence. All of it is still there exactly where they left it, frozen in time. The flags are probably bleached white by now from the intense unfiltered sunlight, but they're still standing, or at least most of them are. Buzz Aldrin said he saw the flag from Apollo 11 get knocked over by the exhaust from the lunar module when they launched to return to Earth, so that one might be lying in the dust. But the others are likely still there, silent monuments to human achievement in the middle of an ancient, airless world. You know, the temperature on the moon is quite extreme. During the lunar day, which lasts about 2 weeks, the temperature in direct sunlight can reach 127 degrees Celsius. That's hot enough to boil water. But during the lunar night, which also lasts about 2 weeks, the temperature can plummet to minus 173 degrees Celsius. That's colder than any place on Earth has ever been. This enormous temperature swing happens because the moon has no atmosphere to trap heat or distribute it around. The heat from the sun just radiates back into space as soon as the sun sets. On Earth, our atmosphere acts like a blanket, keeping things relatively moderate. The moon has no such blanket. It's exposed directly to the harshness of space, baking and freezing in turn, over and over, in a cycle that's continued for billions of years. The moon's surface is covered in a layer of fine dust called regolith. This isn't like the soil we have on Earth. Regolith is made of tiny fragments of rock and glass, broken down over billions of years by the constant bombardment of meteorites and the intense radiation from the sun. It's very fine, almost like powder, and it has a strange smell. The astronauts who walked on the moon said that when they brought the lunar dust back into their spacecraft, it smelled like spent gunpowder or wet ashes. Some described it as a sharp, acrid smell. This smell faded quickly though, probably because the dust was reacting with the oxygen and moisture in the spacecraft. On the moon itself, of course, there's no one to smell it, no air to carry the scent. The regolith just sits there, silent and odorless, covering the ancient bedrock like a blanket of broken glass. This dust was actually one of the bigger challenges for the Apollo missions. It got everywhere. It clung to spacesuits. It worked its way into equipment seals. It was sharp and abrasive and could potentially damage delicate instruments. The astronauts tracked it into the lunar module on their boots, and it floated around in the zero gravity. Eugene Cernan, the last person to walk on the moon, said it was probably the most aggravating environmental factor they had to deal with, but it's also fascinating stuff. Each grain of regolith is covered with tiny craters and pits from micrometeorite impacts. If you looked at lunar dust under a microscope, you'd see that every single particle is a miniature record of bombardment from space, and mixed in with the rock, fragments are tiny beads of glass created when meteorite impacts melted the rock and splashed it around. These glass beads cooled in mid-air and fell back to the surface like little frozen raindrops. Some of them are green, some are orange, depending on what minerals they contain. The Apollo 17 astronauts found a deposit of orange glass beads near their landing site and got very excited, thinking maybe they'd found signs of recent volcanic activity. Later analysis showed the beads were actually ancient, billions of years old, but they were still fascinating. Tiny treasures in the dust waiting billions of years to be discovered. Let's talk about what the Earth looks like from the moon, because it's one of the most beautiful sights imaginable. From the moon, Earth appears about 4 times larger than the moon appears from Earth. It hangs in the black sky, a brilliant blue and white marble swirled with clouds, the only colour in a landscape of grey and black. Unlike the moon, which goes through phases as seen from Earth, Earth doesn't appear to go through phases from most places on the moon. If you're standing on the near side of the moon, the side that faces Earth, then Earth is always in roughly the same place in your sky. It doesn't rise or set. It just hangs there, slowly rotating, showing you different continents and oceans as the hours pass. Because the moon is tidally locked to Earth, if you're standing on the near side, Earth is always visible. If you're standing on the far side, you can never see Earth at all. There's a line around the moon, the boundary between near side and far side, where you could stand and watch Earth rise and set along the horizon. But most places on the moon have either eternal view of Earth or no view at all. The astronauts said that seeing Earth from the moon changed them. It gave them a new perspective on our planet and our place in the universe. When you see the whole Earth at once, all the countries and oceans and continents together, borders seem arbitrary. Problems seem smaller. The fragility and preciousness of our world becomes obvious. Frank Borman, who commanded Apollo 8, said that the one thing that really struck him was how beautiful and fragile and remote Earth looked. Jim Lovell said you realize that everything you've ever known is on that little marble up in the sky, and it's so small you can hide it behind your thumb. These men went to the moon and came back changed, more thoughtful, more aware of how special our planet is. There's a term for this, the overview effect. It's the cognitive shift that happens when you see Earth from space and realize, truly realize, that we're all on this one small world together, floating in the vastness of the cosmos. Perhaps thinking about this as you drift towards sleep, imagining Earth as the astronauts saw it, might give your own worries and stresses a different scale. We're part of something larger, something ancient and beautiful and mysterious. The moon's gravity is much weaker than Earth's, about 1/6 as strong. This means that if you weigh 60 kilograms on Earth, you'd weigh only about 10 kilograms on the moon. You wouldn't have lost any mass, of course, but the moon's gravity wouldn't pull on you as strongly. This weaker gravity is why the astronauts could bounce around so easily, why they could jump much higher and carry equipment that would have been too heavy on Earth. It's also why the moon can't hold onto an atmosphere. The moon's gravity simply isn't strong enough to prevent gas molecules from escaping into space. Earth's stronger gravity keeps our atmosphere wrapped around us like a protective shell. But any atmosphere the moon might have once had has long since drifted away into the void. This is why the sky is black on the moon, why there's no wind, why everything is silent. The moon exists in vacuum, utterly exposed to space. The weaker gravity also means that you could throw a ball much farther on the moon than on Earth. A baseball thrown by a major league pitcher on Earth might travel about 100 meters if thrown at the optimal angle. The same throw on the moon could send a ball more than half a kilometer, and because there's no air resistance, the ball would follow a perfect parabolic arc, just like in a physics textbook. Alan Shepard, the commander of Apollo 14, actually hit golf balls on the moon. He'd smuggled a golf club head up to the moon and attached it to a sample collection tool. In the awkward spacesuit with limited mobility, he swung one-handed and hit 2 golf balls. He famously said that the second one went miles and miles and miles, though later estimates suggest it probably travelled only about 40 meters. Still, those golf balls are up there somewhere, lying in the dust, the strangest golf hazard in the solar system. Someday, perhaps centuries from now, someone might stumble across them and wonder at the playfulness of those early explorers. Now let me tell you about how the moon affects Earth, because the relationship between our planet and its satellite is intimate and profound. The most obvious effect is the tides. The moon's gravity pulls on Earth, and because water can flow, it responds to this pull more readily than solid rock. The ocean on the side of Earth facing the moon bulges outward, pulled by the moon's gravity, and strangely the ocean on the opposite side of Earth also bulges outward, because that water is farther from the moon and thus pulled less strongly, so it's left behind as Earth itself is pulled toward the moon. As Earth rotates through these bulges, we experience high and low tides. Most coastal areas get 2 high tides and 2 low tides each day. The sun also affects tides, though less strongly than the moon because it's much farther away. When the sun and moon align, during a new moon or full moon, their gravitational pulls combine and we get especially high tides called spring tides. When the sun and moon are at right angles to each other during the first and third quarter moons, their pulls partially cancel out and we get smaller tides called neap tides. This dance of gravity has been going on for billions of years, shaping coastlines, influencing marine life, governing when certain fish spawn and when certain birds feed. Before humans understood gravity or knew that the moon was a physical world, they still noticed the connection between the moon and the tides. Ancient peoples knew that the highest tides came with the full moon, and they organized fishing and travel accordingly. The moon was a timekeeper, a calendar in the sky, utterly reliable. The moon also stabilizes Earth's axial tilt. Earth is tilted at about 23.5 degrees relative to its orbit around the Sun, and this tilt is what gives us seasons. Without the moon's gravitational influence, this tilt would vary much more dramatically over time, destabilized by the gravity of other planets, particularly Jupiter and Venus. Computer simulations suggest that without the moon, Earth's axial tilt could vary between 0 and 85 degrees over millions of years. Imagine what that would mean for climate. A world with no tilt would have no seasons, just eternal sameness at each latitude. A world tilted 85 degrees would have seasons so extreme that each pole would experience months of continuous daylight, followed by months of continuous darkness, with temperature swings that would make much of the planet uninhabitable. The moon, our steady companion, prevents this chaos. It keeps Earth's tilt stable, keeps our seasons regular and predictable, makes our world a more hospitable place for complex life. Some scientists think that without the moon, life on Earth might never have evolved beyond simple organisms. We owe our existence, in a very real sense, to that silver light in the night sky. The moon is moving away from us, as I mentioned earlier, and this means that tides were stronger in the past. When the moon was closer, its gravitational pull was more intense. 4 billion years ago, when the moon was perhaps 10 times closer than it is now, the tides would have been enormous, hundreds of meters high, crashing over the primordial continents. The day would have been just 5 hours long, because the tidal forces that slow Earth's rotation were much stronger. Over billions of years, the tides have acted like brakes on Earth's rotation, gradually slowing it down. Energy from Earth's rotation is transferred to the moon, pushing it farther away. Eventually, in the far future, Earth will become tidally locked to the moon, just as the moon is tidally locked to Earth. The same side of Earth will always face the moon, and a day will last about 47 current days. The moon will hang motionless in the sky, always in the same spot, never rising or setting. But this won't happen for billions of years, and by then the sun will be approaching the end of its life anyway. For now, for all of human history past and all of human history to come, we can enjoy the moon's stately progression across the sky, rising in the east and setting in the west, waxing and waning through its phases. Speaking of phases, let's talk about why the moon changes shape in the sky. Of course, the moon doesn't actually change shape. It's always a sphere, always the same. What changes is how much of the sunlit side we can see from Earth. When the moon is between Earth and the sunlit side faces away from us, and we see the dark side, the side that's in shadow. This is a new moon, and the moon is invisible in the sky, or nearly so. Sometimes you can see the dark portion of the moon faintly lit by earthshine, sunlight that reflects off Earth, and then onto the moon. As the moon orbits Earth, we begin to see more and more of the sunlit side. A thin crescent appears, growing thicker each night. This is a waxing crescent. When half the moon is illuminated, we call it a first quarter moon, though it's actually showing us half its face, not a quarter. The name comes from the fact that the moon is a quarter of the way through its orbital cycle. The moon continues to wax, showing us more and more of its sunlit side until we reach the full moon. At full moon, the moon is on the opposite side of Earth from the sun, and the entire face we can see is bathed in sunlight. The full moon rises at sunset and sets at sunrise, hanging in the sky all night long. Then the process reverses. The moon begins to wane. We see a waning gibbous moon, then a third quarter moon, then a waning crescent, and finally we're back to the new moon again. The whole cycle takes about 29.5 days from new moon to new moon. This is called a synodic month, and it's slightly longer than the time it takes the moon to orbit Earth once, which is about 27.3 days. The difference is because Earth is also moving around the sun, so the moon has to travel a bit farther to get back to the same position relative to the sun. Humans have used the moon's phases to keep time for thousands of years. Many calendars are based on the lunar cycle. The Islamic calendar is purely lunar, with 12 lunar months making up a year of about 354 days. The Jewish calendar and the Chinese calendar are lunisolar, incorporating both moon phases and the solar year to keep the seasons aligned. Even in cultures that use solar calendars like the Gregorian calendar we use in much of the world today, we still have months, and that word comes from moon. A month was originally the time from one new moon to the next. Our months are no longer synchronized with the moon's phases, but the connection is still there in the language we use. The full moon has always had special significance for people. There's something primal about it, seeing that bright circle in the sky, knowing it will light your way through the darkness. Before artificial lighting, the full moon was genuinely useful. You could travel at night, work in the fields, hunt, or fish. Many animals are more active during the full moon, taking advantage of the extra light. Some species of coral, for instance, synchronize their spawning with the full moon. Fish tend to bite more readily. Wolves don't actually howl more at the full moon despite the myths, but the extra light does make them more visible when they howl, which might be where the legend came from. Different cultures have different names for the full moons in different months. In many Native American traditions, the full moon in January is called the wolf moon, because wolves were heard howling more at this time of year, perhaps because it's mating season or perhaps because they're hungrier the deep winter. February's full moon is the snow moon for obvious reasons. March brings the worm moon, when the ground begins to thaw and earthworms appear. April's full moon is the pink moon, named after pink wildflowers called wild ground phlox that bloom in early spring. May has the flower moon, June the strawberry moon, July the buck moon when deer grow new antlers. August's full moon is the sturgeon moon, September's the harvest moon, the full moon closest to the autumnal equinox when farmers could work late into the night by moonlight to bring in their crops. October has the hunter's moon, November the beaver moon, and December the cold moon. These names vary by region and culture, of course. They're attempts to connect the celestial rhythm of the moon with the earthly rhythm of seasons and life. Sometimes about once every 2.5 years, we get 2 full moons in a single calendar month. The second of these full moons is called a blue moon, though it's not actually blue in colour. The phrase "once in a blue moon" meaning something rare comes from this phenomenon. Very occasionally, atmospheric conditions can make the moon actually appear blue. If there's a volcanic eruption or a large forest fire, the particles in the atmosphere can scatter light in such a way that the moon looks blue or even greenish. This is extremely rare though. Most blue moons are blue only in name, and then there are eclipses. A lunar eclipse happens when Earth passes directly between the Sun and the Moon, and Earth's shadow falls on the Moon. This can only happen during a full moon, but it doesn't happen every full moon because the Moon's orbit is tilted about 5 degrees relative to Earth's orbit around the Sun. Usually the Moon passes above or below Earth's shadow, but a few times a year the alignment is just right and we get an eclipse. During a total lunar eclipse, the Moon passes completely into Earth's shadow. You might think this would make the Moon disappear completely, but instead it usually turns a deep red or orange colour. This happens because Earth's atmosphere bends some sunlight around the edge of the planet, and this bent light reaches the Moon. The atmosphere filters out the blue light and lets through the red, so the Moon glows with a coppery red light. It's often called a blood moon, and in ancient times these eclipses frightened people. They thought the Moon was dying or being devoured. Now we understand what's happening, but a total lunar eclipse is still a beautiful, eerie sight. The Moon hanging in the sky, transformed from its usual silver white to deep red, all the sunrises and sunsets on Earth projected onto the lunar surface. A solar eclipse is even more dramatic, though in a different way. This happens when the Moon passes directly between Earth and the Sun, and the Moon's shadow falls on Earth. The Moon blocks out the Sun. Day turns to night. Stars appear in the middle of the afternoon. The temperature drops. Animals become confused. Total solar eclipses are rare at any given location, happening only about once every 400 years on average. But they do happen somewhere on Earth every 18 months or so. The path of totality, the area where the Sun is completely blocked, is usually only about 100 kilometers wide and a few thousand kilometers long. If you're lucky enough to be in this path, you witness one of nature's most spectacular sights. The Moon covers the Sun exactly, revealing the Sun's corona, the outer atmosphere that's usually too faint to see against the Sun's bright surface. The corona streams out in delicate wisps and loops, white and ghostly. For a few minutes, day becomes night, and you can see planets and bright stars. Then the Moon moves on, the Sun emerges, and the world returns to normal. The fact that total solar eclipses are possible is actually a remarkable coincidence. The Sun is about 400 times larger than the Moon, but it's also about 400 times farther away. This means that from Earth, the Sun and Moon appear almost exactly the same size in the sky. This won't always be true. As the Moon drifts away from Earth, it will appear smaller and smaller. Eventually, millions of years from now, the Moon will be too far away to completely cover the Sun. There will be no more total solar eclipses, only annular eclipses where a ring of sunlight remains visible around the Moon. But for now, we live in a special time when the cosmic alignment is just right. Our ancestors saw total solar eclipses, and our descendants will too for thousands of generations. But eventually this window will close. The universe will move on, indifferent to the beauty it's taking away. Let me tell you about the Moon's birth now, about where it came from, because it's a story billions of years in the making. Scientists think the Moon formed from a catastrophic collision early in Earth's history. About 4.5 billion years ago, when the solar system was still young and chaotic, a Mars-sized object called Theia crashed into the young Earth. The impact was unimaginably violent. Theia was destroyed, and a huge chunk of Earth was blasted into space. The impact melted both bodies, spraying vaporized and molten rock into orbit around Earth. This debris, this cloud of destruction, gradually coalesced back together, pulled by gravity. The heavier material fell back to Earth, but enough remained in orbit to form the Moon. The Moon was born from Earth's own substance, mixed with the remains of Theia. In a very real sense, the Moon is made of Earth, a piece of our planet that was torn away and reformed into a new world. When the Moon first formed, it was much closer to Earth, perhaps just 30,000 kilometers away, instead of the nearly 400,000 kilometers it is now. It would have appeared 15 times larger in the sky than it does today, dominating the heavens. The month would have been just a few days long, and the tides would have been immense. The Moon was also much hotter, still molten from the energy of the impact and the decay of radioactive elements. Over millions of years it cooled and solidified. The surface froze into a crust of lighter rock, while the interior remained molten for a while longer. Then came the late heavy bombardment, a period about 4 billion years ago when a sudden increase in asteroid and comet impacts pelted the inner solar system. The Moon, with no atmosphere to protect it, was cratered and scarred. Some of these impacts were so large that they cracked the crust and allowed lava to well up from the interior, creating those dark maria we see today. The last of these lava flows happened about 1 billion years ago. Since then, the Moon has been geologically dead, its interior cooled and solid, its surface changed only by the occasional impact. The rocks that the Apollo astronauts brought back from the Moon have helped us understand this history. Between 1969 and 1972, the 6 Apollo missions that landed on the Moon brought back a total of 382 kilograms of lunar samples. These rocks have been studied intensively, and they've told us the Moon's story. Some of the rocks are incredibly old, over 4 billion years, among the oldest rocks we have from anywhere in the solar system. They contain minerals that formed in the heat of the Moon's creation. Other rocks are basalts from the Maria, dark and dense, formed when lava cooled on the lunar surface. These rocks have textures and compositions that tell us about the conditions in which they formed. And mixed among the rocks are bits of glass and fragments from meteorite impacts, evidence of the constant bombardment the Moon has endured. One of the most interesting things scientists discovered from the lunar rocks is that the Moon has water. Not liquid water, obviously, but water molecules locked in the minerals and ice into these permanently shadowed craters I mentioned earlier. This was a surprise. Early theories about the Moon's formation suggested it should be bone dry, any water vaporized by the heat of the impact, but water is there nonetheless. Some of it might have been delivered by comets, but some might be produced on the Moon itself. When high-energy particles from the Sun, called the solar wind, strike the lunar surface, they can interact with oxygen in the rocks and create water molecules. It's not much water, just a few hundred parts per million, but it's there. In the future, if we establish permanent bases on the Moon, this water will be precious. We could extract it from the soil, or harvest ice from those shadowed craters, providing drinking water and rocket fuel for lunar explorers. The Moon has no magnetic field today, but the rocks reveal that it once did. Some lunar samples are magnetized, showing that when they cooled and solidified, there was a magnetic field present to align the magnetic minerals. This suggests that the Moon once had a liquid core that generated a magnetic field through a dynamo process, similar to how Earth's magnetic field is generated today. The Moon's core cooled and solidified billions of years ago though, and the magnetic field disappeared. Now the Moon is naked to the solar wind, with no magnetic shield to protect it. Charged particles from the Sun strike the surface directly, slowly eroding it, altering the chemistry, giving the regolith its distinctive properties. Let's talk about moonquakes for a moment. Yes, the Moon has quakes, though they're much weaker than earthquakes. The Apollo missions left seismometers on the lunar surface, and these instruments detected thousands of moonquakes over several years. There are several types of moonquakes. Deep moonquakes occur about 700 kilometers below the surface, probably caused by the gravitational pull of Earth stressing the Moon's interior. These are small and not very interesting. Thermal moonquakes are caused by the expansion and contraction of the lunar crust as it heats up during the lunar day and cools down during the lunar night. These are also small, but there are also shallow moonquakes, occurring less than a few hundred kilometers below the surface, and some of these can be quite strong. A few have registered up to magnitude 5 on the Richter scale. These shallow moonquakes are mysterious. Scientists aren't entirely sure what causes them. They might be related to faults in the crust or to the slow cooling and contraction of the Moon's interior. Whatever the cause, they make the Moon vibrate like a bell. Because the Moon is solid all the way through and has no water to dampen vibrations, a moonquake can make the surface ring for hours, the seismic waves bouncing back and forth inside the Moon like sound in an empty room. There are also meteorite impacts, of course. The Moon is constantly being hit by small meteorites and occasionally by larger ones. The Apollo seismometers detected the impacts of meteorites, a distinctive sharp jolt followed by ringing. On average, the Moon is hit by about 2,000 meteorites a day, most of them tiny, grains of dust. About once a week, a meteorite the size of a golf ball hits. Every few months, something the size of a basketball. Every few years, a boulder-sized meteorite. And every few million years, something truly enormous, creating a new crater visible from Earth with telescopes. These impacts are part of the ongoing process that shapes the Moon's surface, slowly grinding the rocks into finer and finer dust, adding new craters on top of old ones, a palimpsest written over billions of years. Now let me tell you something that might seem strange but is quite beautiful. The Moon makes music, not the way we think of music with melody and rhythm, but in the vibrations and resonances of moonquakes and impacts. Scientists have taken the seismic data from the Apollo missions and sped it up so the frequencies are audible to human ears. What you hear is eerie and otherworldly, low rumbles and high pings, the Moon singing to itself in the silence of space. It's a reminder that even a dead world has a kind of life, a presence, a voice if you know how to listen. When you look up at the full moon, especially on a clear night, you can sometimes see rays extending from some of the craters. These rays are bright streaks that radiate outward from impact craters, sometimes for hundreds of kilometers. They're made of material that was blasted out during the impact, pulverized rock that was thrown across the landscape. The rays are brighter than the surrounding terrain because the material is fresher, not yet darkened by billions of years of exposure to the solar wind and micrometeorite bombardment. One of the most prominent ray systems comes from the crater Tycho, near the Moon's south pole. Tycho is a relatively young crater, only about 100 million years old, and its rays are still bright and dramatic. You can see them with the naked eye during a full moon, a beautiful starburst pattern radiating from a point near the bottom of the lunar disk. The moon has been a source of wonder and inspiration for all of human history. Every culture has moon myths and moon gods. The ancient Greeks had Selene, goddess of the moon, driving her chariot across the night sky. The Romans called her Luna. In Hindu mythology, the moon is Chandra, associated with the mind and emotions. In Chinese mythology, the moon is home to Chang'e, who drank an elixir of immortality and floated up to the moon, where she lives forever in the Moon Palace, with only a jade rabbit for company. Native American traditions are filled with moon stories, tales of how the moon came to be, why it changes shape, why it governs the tides and the seasons. The moon has inspired countless works of art and literature. Poets have written about the moon for thousands of years. There's something about moonlight that evokes emotion, that makes us reflective and contemplative. Moonlight is softer than sunlight, gentler, mysterious. It doesn't reveal everything clearly, but casts shadows and creates silhouettes. Things look different by moonlight, dreamlike and romantic. Lovers have met by moonlight, sailors have navigated by moonlight, poets have wandered by moonlight composing verses. The moon is associated with femininity in many cultures, with cycles and change and the passage of time. It waxes and wanes like the cycles of life, birth and death, growth and decay, a reminder that everything changes, nothing stays the same. In the early days of astronomy, when people first turned telescopes toward the moon, what they saw amazed them. Galileo Galilei was one of the first to observe the moon through a telescope in 1609. He saw mountains and craters, and he realized that the moon was not a perfect, smooth sphere as Aristotle had taught, but a world of its own with terrain and features. This was revolutionary. It suggested that the heavens were not fundamentally different from the earth, that the same physical laws applied everywhere. It was one of the first steps toward our modern understanding of the universe. Later astronomers mapped the moon in increasing detail. They gave names to the features they saw, drawing on Latin and Greek, on mythology and poetry. The Sea of Tranquility, Mare Tranquillitatis, where Apollo 11 landed. The Ocean of Storms, Oceanus Procellarum. The Sea of Serenity, Mare Serenitatis. These are peaceful, contemplative names for dry, airless plains of rock, but they reflect the mood the moon inspires. Even knowing that these seas are not water, that the moon is a barren, lifeless place, we still find it beautiful. We still project onto it our hopes and dreams, our sense of mystery and wonder. This space age brought a new relationship with the moon. No longer just a distant object to observe and admire, the moon became a destination, a place we could actually go. The Soviet Union's Luna 2 was the first human-made object to reach the moon, crash landing on the surface in 1959. Luna 3 photographed the far side of the moon for the first time that same year. The United States followed with the Ranger missions, which sent back photographs as they plummeted toward the lunar surface. Then came the Surveyor missions, which soft-landed and sent back images from the surface. The Lunar Orbiter missions mapped the moon in detail, looking for safe landing sites for the Apollo missions. And then, on July 20th, 1969, Neil Armstrong and Buzz Aldrin landed on the moon. "The Eagle has landed," Armstrong radioed, and those 4 words announced that humanity had reached another world. A few hours later, Armstrong climbed down the ladder of the lunar module and stepped onto the surface. "That's one small step for man," he said. Though the transmission was garbled and the A was inaudible, one giant leap for mankind. It was a moment that transcended nationality and politics. For one brief, shining moment, all of humanity was united in this achievement. People all over the world watched on television as Armstrong and Aldrin walked on the moon, planted a flag, set up experiments, collected rocks. They spent just over 2 hours outside the lunar module, then climbed back inside, launched from the surface and returned home. The whole mission took 8 days. 5 more Apollo missions landed on the moon after Apollo 11. Each mission went to a different location, exploring different types of terrain, answering different scientific questions. Apollo 12 landed in the ocean of storms, proving that NASA could target a landing site with precision. Apollo 14 landed in the Fremero Highlands, collecting rocks from the ancient crust. Apollo 15, 16 and 17 were extended missions, with more supplies, longer stays and the lunar rover vehicle. These astronauts could drive across the surface, exploring areas kilometers from their landing sites. They collected hundreds of kilograms of rocks, took thousands of photographs, set up experiments that sent data back to Earth for years. Eugene Cernan, commander of Apollo 17, was the last person to walk on the moon in December of 1972. As he climbed back into the lunar module for the last time, he said, "We leave as we came, and God willing, as we shall return with peace and hope for all mankind." But no one has returned. More than 50 years have passed, and the moon has been empty of human presence all that time. Why haven't we gone back? The reasons are complicated, involving politics and budgets and changing priorities. The Apollo program was enormously expensive, consuming a significant fraction of the US federal budget at its peak. It was driven by the Cold War competition with the Soviet Union, a desire to demonstrate technological superiority. Once that goal was achieved, the political will to continue faded. The final 3 planned Apollo missions, 18, 19 and 20, were cancelled to save money. The focus shifted to the space, shuttle and the International Space Station, maintaining a human presence in low Earth orbit rather than venturing farther. But interest in returning to the moon has been growing again. NASA's Artemis program aims to land humans on the moon in the 2020s, including the first woman and the first person of color to walk on the lunar surface. Other countries, including China and India, have sent robotic missions to the moon and have plans for human missions in the future. Private companies are also getting involved, developing technologies to land cargo and eventually people on the moon. It seems likely that within the next decade or 2, humans will return to the moon, this time perhaps to stay. A permanent lunar base is a dream that many people share. Such a base could serve as a laboratory for scientific research, a test bed for technologies needed for Mars missions, a mining operation to extract lunar resources, or even a tourist destination. Building a base on the moon would be challenging, though. The environment is harsh, the radiation is intense, the temperature swings are extreme, and everything would have to be brought from Earth or manufactured on the moon from local materials. But it's possible. We have the technology, or at least the beginnings of it. what we need is the will and the resources. Imagine what a lunar base might look like. Perhaps a cluster of inflatable habitats buried under lunar regolith for protection from radiation and micrometeorites. Solar panels spread across the surface, soaking up sunlight during the 2-week lunar day and storing energy in batteries for the 2-week lunar night. Greenhouses where plants grow in artificial light, providing food and oxygen. Mining equipment extracting ice from the shadowed craters, melting it, purifying it, splitting it into hydrogen and oxygen. A landing pad where spacecraft arrive and depart, ferrying supplies and personnel to and from Earth, and people, scientists and engineers and technicians living and working on the moon, conducting experiments, exploring, building, preparing for the next step outward to Mars and beyond. Some people dream of even more than a base. They imagine lunar cities, enclosed domes where thousands of people could live, entire communities transplanted to another world. They imagine industries on the moon, factories manufacturing products in the low gravity that would be impossible to make on Earth. They imagine observatories on the far side of the moon, where radio telescopes could listen to the universe undisturbed by Earth's radio noise. These visions may seem like science fiction, but so did landing on the moon once. Who knows what the future holds? The moon has no life on it as far as we know. No microbes in the soil, no plants clinging to the rocks, nothing. It's one of the most sterile environments in the solar system. The radiation, the vacuum, the temperature extremes, the lack of water, all make life as we know it impossible. But the Apollo astronauts may have inadvertently contaminated the moon. Despite efforts to sterilize equipment, it's likely that some Earth microbes hitched a ride on the lunar modules and other equipment left behind. Most of these would have died quickly in the harsh conditions, but some bacteria can form extremely hardy spores that might survive for years or even decades. When Apollo 12 astronauts retrieved parts of the Surveyor 3 probe that had been sitting on the moon for 2.5 years, they found bacteria inside the camera. These bacteria had apparently survived the journey to the moon, the lunar environment, and the journey back. Later studies suggested this might have been contamination during handling after the parts were brought back to Earth, but it raised interesting questions about how resilient life can be. This question of contamination becomes important as we think about future missions. If we're going to search for life on other worlds, we need to be careful not to bring Earth life with us and confuse the results. The moon is probably safe to contaminate since it's so clearly lifeless, but Mars and some of the moons of Jupiter and Saturn might harbour life, and we need to be careful. Conversely, when we bring samples back from other worlds, we need to make sure we're not accidentally bringing back alien microbes that could harm Earth's biosphere. These are questions that planetary protection officers spend their time thinking about, developing protocols and procedures to keep Earth life and alien life separate. The moon's influence on Earth extends beyond tides and axial stability. There's some evidence that the moon might affect biological rhythms. Many marine organisms time their reproductive cycles to the moon. Corals, as I mentioned, spawn during the full moon. Certain species of crabs release their larvae on specific moon phases. Some insects emerge or mate according to lunar cycles. Even some mammals show lunar rhythms in their behaviour. Of course, much of this could be due to the change in light levels or the tides rather than some mysterious lunar influence. But the correlation is there. Humans have long believed that the moon affects us too. The word lunatic comes from lunar, the Latin word for moon, because people once thought that madness was caused by the moon, particularly the full moon. There's no scientific evidence for this though. Studies have repeatedly shown no correlation between the full moon and emergency room visits, crime rates, psychiatric episodes, or any other measure of human behaviour. It's a persistent myth though, perhaps because we notice unusual events more when they coincide with the full moon, and forget about all the times they don't. The moon is such a prominent feature of the night sky that it's natural to think it must have some effect on us. But the truth seems to be that the moon's main influence on human beings is cultural and psychological, not physical. That psychological influence, though, is real and powerful. The moon shapes our calendars, our language, our myths, our art. It's a symbol of mystery and change, of cycles and time, of the night and the unknown. It's associated with romance and longing, with madness and transformation. Werewolves transform under the full moon in the old legends, ordinary people becoming monsters. The moon has often been seen as feminine, associated with goddesses and with the cycles of the female body, both following a roughly monthly rhythm. In tarot, the moon card represents illusion, intuition, the unconscious mind, things hidden and mysterious. Looking at the moon can be a meditative experience. Its silent presence, its slow movement across the sky, its changing phases all invite contemplation. You can watch the moon rise, big and orange on the horizon, then climb higher and fade to silver white. You can watch it over the course of weeks, growing from a thin crescent to a full circle and back again. You can notice where it rises and sets, how its path across the sky changes with the seasons. People who pay attention to the moon often find that they feel more connected to natural rhythms, more aware of time passing, more attuned to the world around them. There's a particular phase of the moon that many people find especially beautiful. The crescent moon just after sunset, hanging low in the western sky, with earthshine faintly illuminating the dark portion. You can see the whole disk of the moon, not just the bright crescent, because sunlight reflected from Earth is lighting up the moon's night side. It's a reminder that from the moon, Earth would appear bright and almost full at this time, shining down on the lunar landscape with its blue and white light. This earthshine is sometimes called the old moon in the new moon's arms, a poetic phrase for a lovely sight. The moon's orbit around Earth is not circular but elliptical, which means the moon's distance from Earth varies. When the moon is at the closest point in its orbit, called perigee, it's about 360,000 kilometers from Earth. When it's at the farthest point, called apogee, it's about 405,000 kilometers away. This difference is enough to make the moon appear noticeably larger and brighter at perigee than at apogee. When a full moon coincides with perigee, we get what's sometimes called a supermoon, a full moon that appears up to 14% larger and 30% brighter than a full moon at apogee. The difference is subtle though, and you probably wouldn't notice unless you compared photographs taken at different times. Still, a supermoon is a nice excuse to go outside and look at the moon, and that's never a bad thing. Conversely, when a full moon occurs at apogee, some people call it a micromoon, though this term isn't used as widely. The moon looks slightly smaller and dimmer, but it's still beautiful. In fact, all moons are beautiful, whether super or micro, full or crescent, rising or setting. Each has its own character, its own mood, The moon doesn't produce its own light, of course. It shines with reflected sunlight. The moon's surface is actually quite dark, reflecting only about 12% of the sunlight that hits it. This is similar to the reflectivity of worn asphalt. If the moon were more reflective, like fresh snow which reflects 90% of sunlight, the full moon would be much brighter, bright enough to read by comfortably. As it is, the full moon provides just barely enough light to read large print if your eyes are dark adapted. It's enough light to walk by, to see where you're going, but not enough for fine detail. This dimness is part of the moon's charm. It doesn't overwhelm the darkness, but softens it, makes it more welcoming. The colour of moonlight is often described as silver or blue, but moonlight is actually almost the same colour as sunlight, just much dimmer. The reason moonlight looks bluish to our eyes is related to how our vision works. We have two types of photoreceptor cells in our eyes: cones, which work in bright light and see colour, and rods, which work in dim light but don't see colour as well. Rods are more sensitive to blue and green light than to red light. In moonlight, our cones aren't getting enough light to work properly, so our rods take over. This means we see things in shades of grey, but with a bias toward the blue-green end of the spectrum. So moonlight looks bluish, even though it's technically the same colour as sunlight. This is called the Purkinje effect, named after the scientist who discovered it. Moonlit landscapes have a special quality. Colours are muted, contrasts are softened, shadows are deep and mysterious. Moonlight doesn't show texture as well as sunlight does, so surfaces look smoother, more uniform. This can make familiar landscapes look strange and unfamiliar, almost magical. Photographers who work with moonlight often capture this quality, creating images that look dreamlike and otherworldly. The moon has been photographed more than almost any other celestial object. Amateur astronomers point their telescopes at it and capture stunning images of craters and mountains. Professionals use huge telescopes and sophisticated cameras to map every detail. Spacecraft in orbit around the moon have photographed it at resolutions fine enough to see the tracks left by the lunar rovers, the descent stages of the lunar modules, even the footprints of the astronauts. These images are a remarkable resource. Anyone with an internet connection can explore the moon in incredible detail, zooming in on specific features, planning imaginary journeys across the surface. And speaking of journeys, let's think about what it would be like to actually walk on the moon. The astronauts described it as an experience unlike anything else. The gravity is low enough that you can jump surprisingly high, but not so low that you feel weightless. You move in slow bounding leaps. The ground crunches under your boots. Dust kicked up by your feet follows a perfect parabolic arc and falls back to the ground without any of the swirling that would happen on Earth. The sky above is black, even in full sunlight, and stars are visible. The sun is intensely bright, a hard white point that would blind you if you looked at it. The landscape is grey and tan and brown, monotonous in colour but varied in texture. Everything is sharply defined, with no atmospheric haze to soften distant features. Hills that look close might be kilometres away. It's easy to misjudge distances. The horizon is much closer than on Earth because the moon is smaller. If you're standing on a flat plain, the horizon is only about 2.5 kilometres away, compared to about 5 kilometres on Earth. This gives the moon a more intimate feel, a sense that you're on a small world. And indeed you are. the Moon's circumference is only about 11,000 kilometers, compared to Earth's 40,000 kilometers. You could walk around the Moon in about a year if you walked 8 hours a day, though you'd have to deal with the temperature extremes and carry enough supplies to last, so it's not actually practical. But the point is, the Moon is a small world, comprehensible in size, a place you could imagine exploring thoroughly. Some of the most striking photographs from the Apollo missions show Earthrise, the view of Earth coming up over the lunar horizon. This is a sight you can only see from lunar orbit or from certain locations on the Moon where Earth rises and sets. From most places on the near side of the Moon, Earth just hangs in the sky in the same place all the time. But from orbit, as the spacecraft circles the Moon, Earth appears to rise above the barren landscape, a beautiful blue and white jewel against the black sky. William Anders, who photographed the famous Earthrise image from Apollo 8, said later that we came all this way to explore the Moon, and the most important thing is that we discovered the Earth. That photograph, showing our whole planet rising above the desolate moonscape, has become one of the most iconic images of the 20th century. It helped inspire the environmental movement, giving people a visceral sense of Earth's beauty and fragility. The Moon has no magnetic field now, as I mentioned, but it does have faint magnetic anomalies, spots where the rocks are more magnetic than surrounding areas. These are thought to be remnants of ancient impacts. When a large asteroid or comet struck the Moon, the impact created a cloud of hot plasma that interacted with any magnetic field present at the time, creating a locally magnetized region that persisted even after the global magnetic field disappeared. These magnetic anomalies aren't strong, but they're measurable, and they tell us something about the Moon's past. The Moon's surface is also electrically charged in places. The side facing the Sun has a slight positive charge because ultraviolet light from the Sun knocks electrons off atoms on the surface. The side facing away from the Sun, in shadow, has a slight negative charge because electrons from the solar wind accumulate there. This charge isn't strong, but it's enough to make lunar dust behave oddly. Dust particles can become charged and repel each other, causing dust to levitate above the surface or stick to surfaces it touches. The Apollo astronauts noticed that lunar dust clung to everything: their spacesuits, their equipment, even the inside of the lunar module. This electrostatic attraction made it very difficult to keep things clean. There's actually a tenuous atmosphere on the Moon, though calling it an atmosphere is generous. It's more like an exosphere, so thin that the atoms almost never collide with each other. The pressure at the lunar surface is about 10 trillion times less than Earth's atmospheric pressure. This exosphere is made up of atoms that have been blasted off the surface by the solar wind, by meteorite impacts, or by radioactive decay. The most common elements are helium, neon, hydrogen, and argon. During the lunar day, atoms are also released from the surface as it heats up. This exosphere is constantly replenished because the atoms escape into space, but it never gets any thicker because the supply of new atoms is so limited. It's the barest hint of an atmosphere, a whisper of gas around an otherwise airless world. There are also transient gas releases on the Moon, things that look like outgassing events or small volcanic eruptions. These are called transient lunar phenomena, and they've been reported by observers for centuries. People have seen temporary glows, changes in colour, or obscurations of lunar features. Most of these reports are probably due to observing conditions on Earth, like atmospheric turbulence or light reflections in telescopes, but some might be real. Perhaps there are pockets of gas trapped underground that occasionally get released. Perhaps there are still tiny amounts of volcanic activity deep inside the moon. We don't know for sure. The moon keeps some secrets still. The moon's shape isn't quite spherical. It's slightly squashed, an oblate spheroid, because of the tidal forces from Earth. The diameter of the moon is about 43 kilometers greater along the Earth-Moon axis than it is pole to pole. This isn't enough to see with the naked eye, but it's measurable. The moon is also lumpy, with variations in the strength of gravity across its surface. These variations are called mass concentrations or mascons, and they're caused by denser material under some parts of the surface, probably related to the large impact basins. Spacecraft orbiting the moon have to account for these mascons in their navigation, or they'll slowly drift off course. Let's think about what it would take to live on the moon permanently. You'd need shelter from radiation, so you'd probably live underground or in habitats covered with lunar soil. You'd need a source of oxygen, either brought from Earth or extracted from lunar rocks. Many lunar minerals contain oxygen chemically bound to other elements, and with enough energy you can break those bonds and free the oxygen. You'd need water, either mined from ice or manufactured by reacting hydrogen with lunar minerals. You'd need food, either brought from Earth or grown in greenhouses. You'd need power, probably from solar panels during the day and batteries or nuclear reactors for the night. You'd need to deal with the dust, which gets everywhere and is sharp enough to damage equipment. You'd need to protect yourself from meteorites, which can strike without warning since there's no atmosphere to burn them up. You'd need to deal with the psychological challenges of living in a confined space, far from Earth, with the same few people for months or years at a time. Despite all these challenges, people want to live on the moon. There's something about the idea of living on another world that captures the imagination. Perhaps it's the ultimate adventure, the ultimate frontier. Perhaps it's a way to ensure humanity's survival, spreading our species to more than one world so a single disaster can't wipe us out. Perhaps it's simply curiosity, the desire to explore and learn and push boundaries. Whatever the reason, it seems likely that someday, perhaps soon, there will be people living on the moon, looking up at the Earth in their sky the way we look up at the moon in ours. The moon could become a resource for humanity in other ways too. The lunar regolith contains helium-3, a rare isotope of helium that's deposited by the solar wind. Helium-3 is potentially useful as fuel for fusion reactors, which could provide clean, abundant energy. There's more helium-3 on the moon than on Earth, because Earth's magnetic field deflects the solar wind while the moon is fully exposed to it. Mining helium-3 from the moon would be difficult and expensive, but if fusion power becomes a reality, it might be worth it. The moon also has other valuable materials, rare earth elements and metals that could be used for manufacturing. Mining the moon might sound like science fiction, but companies and governments are already thinking about how to do it. The moon could also be a good place for astronomy. Telescopes on the far side of the moon would be shielded from Earth's radio noise, able to detect faint signals from the early universe without interference. The moon has no atmosphere to distort light, so optical telescopes would have incredibly clear views. The low gravity means you could build very large structures without them collapsing under their own weight. A radio telescope on the far side of the moon could revolutionize our understanding of the early universe, detecting the faint signals from the first stars and galaxies. An optical telescope could study exoplanets in detail, perhaps even detecting signs of life on distant worlds. But beyond all the practical reasons for going to the moon, there's something deeper, something about the human spirit that longs to explore. We've been looking at the moon for all of human history, wondering about it, imagining what it would be like to go there. And now we can. We have the technology, the knowledge, the capability. Going to the moon is hard, but it's possible. It's within our reach, and in doing so, we connect with that ancient human urge to explore, to see what's over the horizon, to venture into the unknown. The moon is patient. It's been there for billions of years, and it will be there for billions more. It doesn't care whether we visit it or not, but we care. We look up at the moon and we wonder, we imagine, we dream. And sometimes, if we're lucky, we turn those dreams into reality. As you lie here, comfortable and warm, getting ready to drift off to sleep, maybe you can imagine the moon overhead, silent and luminous, travelling its ancient path across the sky. It's been there every night of your life, every night of every life that's ever been lived. It watched over the dinosaurs, over the first humans, over all the empires and civilizations that have risen and fallen. It will watch over future generations, over whatever comes after us. It's a constant in a changing world, a reminder that some things endure, that some beauties are timeless. The moon asks nothing of us. It just exists, reflecting the sun's light, pulling at the tides, stabilizing Earth's axis, being beautiful. We could ignore it completely and it would make no difference to the moon, but we don't ignore it. We look at it, we study it, we write poems about it, we dream about it. We've sent robots to it and people to it. We've brought pieces of it back to Earth to study, and someday we'll return, perhaps to stay. For now, though, the moon is up there and we are down here, separated by hundreds of thousands of kilometers of vacuum. But in another sense, we're not separated at all. The moon is made of Earth's own substance, blown into space by that ancient collision, and reformed. The moon and Earth are partners, dancing together through space, connected by gravity and history. When you look at the moon, you're looking at a piece of our planet's past, a record of where we came from, and a hint of where we might go. Let the moon's light fill your mind as you drift towards sleep. Imagine its silver glow, soft and gentle. Imagine the slow change of its phases, the rhythm of waxing and waning, a rhythm as old as the earth itself. Let go of the day's worries. They're so small compared to the vastness of the moon, the vastness of space, the vastness of time. You're part of something larger, something ancient and beautiful and mysterious. The moon is there, always there, whether you see it or not. Behind the clouds, behind the daylight, the moon is always present. It rises and sets, grows full and fades to new, follows its path across the sky with absolute reliability. In a world that often feels chaotic and unpredictable, the moon is something you can count on. It will be there tomorrow night, and the night after, and the night after that. As you sink deeper into sleep, maybe you can imagine yourself on the moon, standing in the sea of tranquility where Apollo 11 landed. The Earth hangs above you, blue and beautiful. the only colour in a landscape of grey. The silence is complete. There's no sound at all, no wind, no birds, no distant traffic, just silence. And in that silence there's a kind of peace, a stillness that's hard to find on busy, noisy earth. You're weightless, almost, able to bounce and leap with each step. The ground crunches softly under your boots. You can see the tracks you've left behind you, sharp and clear in the dust. They'll last for millions of years, undisturbed, a record of your passage. Ahead of you, the landscape rolls gently, crater within, crater stretching to the close horizon. Above you, the black sky is filled with stars, more stars than you've ever seen, brilliant and unwavering. You feel small, but not insignificant. You're part of this universe, made of the same atoms as the moon beneath your feet and the stars above your head. The iron in your blood was forged in the heart of an exploding star billions of years ago. The calcium in your bones was created in the fusion furnace of ancient suns. You're made of stardust, and standing on the moon, that fact feels real in a way it never did on Earth. You take a long, slow breath, though of course you're imagining all this as you fall asleep in your comfortable bed. In reality, on the moon, you'd be inside a spacesuit, breathing recycled air, protected from the vacuum and the radiation by layers of fabric and metal. But in your imagination, you can be there directly, feeling the texture of the lunar soil, seeing the stark beauty of the landscape, experiencing the profound silence. And then you look up at the earth again, and it's so beautiful it almost hurts. All that blue, all that white, all that life and colour and movement. From here, you can't see any borders, can't see any conflicts, can't see any of the things that divide us. You just see one world, one home, one precious blue marble in the vastness of space. You realise that everyone you've ever known, everyone you've ever loved, everyone who's ever lived, they're all on that blue marble. Every human drama, every triumph and tragedy, every laugh and tear, all happening right there on that small world. And it's so fragile, so delicate. Just a thin shell of air and water and life wrapped around a ball of rock, floating in an endless ocean of space. But it's also resilient. Life has survived on Earth for billions of years, through ice ages and asteroid impacts, through volcanic eruptions and changing climates. Life adapts, persists, finds a way. And now life, in the form of human beings, has reached out to touch another world. We've left our footprints on the moon. We've looked back at Earth from a new perspective. We've changed, grown, learned. Maybe someday people will be born on the moon. Children who grow up looking at Earth in their sky, the way we grew up looking at the moon in ours. They'll bounce and leap in the low gravity, and Earth gravity will feel crushingly heavy if they ever visit. They'll have their own culture, their own traditions, their own relationship with the moon. To them, the moon won't be a distant romantic object. It will be home, familiar and ordinary. Earth will be the distant, beautiful world, the place their ancestors came from. But that's far in the future. For now, the moon is still a special place, visited by only a handful of people, a destination that exists mostly in our imaginations and our dreams. As you drift deeper into sleep now, let the moon watch over you. Imagine its light streaming through your window, silver and soft, blessing you with its ancient glow. The moon has watched over sleepers for billions of years. It watched over your parents and grandparents, over their parents and grandparents, back through countless generations. It watched over ancestors you'll never know, who lived in times and places you can barely imagine. And it will watch over your children and grandchildren, over generations yet unborn. You're part of that chain, that long line of people who have looked up at the moon and wondered. And now you have more answers than they did. You know what the moon is made of, how it formed, why it changes phases, how far away it is. You've seen photographs from its surface. You've heard the voices of people who walked there. The moon is no longer a complete mystery, but it's still full of wonder. Knowledge doesn't diminish wonder. If anything, it increases it. The more you know about the moon, the more amazing it becomes. So sleep now, with the moon in your mind. Let its gentle rhythms soothe you. Waxing and waning, rising and setting, the moon follows its path with the patience of ages. There's no rush, no hurry, no stress, just the slow, steady progress of the moon through space and time. Let that steadiness calm you, ground you, help you release the tensions of the day. You're safe here, warm and comfortable, while the moon glides silently overhead. The same moon that's shining on you now is shining on people all over the world, in different time zones, different countries, different circumstances. We're all under the same moon, all sharing this one satellite, this companion world that's been with Earth since the beginning. And if you dream tonight, maybe you'll dream of the moon, walking across its ancient surface, floating weightless in its gentle gravity, looking back at Earth hanging in the black sky. Or maybe you'll dream of something else entirely. Either way, the moon will be there when you wake up, ready to begin its nightly journey across the sky once again. The moon is constant, the moon is patient, the moon is beautiful. And so, my friend, are you. You're part of this vast, ancient, beautiful universe, connected to everything, to the moon and the stars and the earth and all of life. You're made of atoms that were forged in the hearts of stars, cycling through the cosmos, taking form for a brief time as you, experiencing the universe, being part of the universe, experiencing itself. Rest now. Let the moon's light fill you with peace. Let its ancient presence remind you that you're part of something larger, something that transcends the small worries of daily life. The moon has seen civilizations rise and fall, has seen species come and go, has seen continents drift and climates change. It has perspective that we lack, a view across deep time that makes our brief lives seem like a flicker. But that flicker matters. Your life matters. You matter. And the moon, in its silent way, witnesses your existence, as it witnesses all existence on Earth. You're seen. You're held. You're part of the grand dance of the cosmos. So sleep peacefully, knowing that the moon is there, patient and constant, watching over you as it has watched over Earth for billions of years. Sleep deeply, knowing that you're connected to everything, that you're made of stardust and magic, that you're both infinitesimally small and infinitely important. The moon asks nothing of you. It just exists, being beautiful, being mysterious, being itself. And that's enough. You too can simply exist, simply be yourself, and that's enough. You don't have to prove anything, achieve anything, become anything other than what you are. You're already part of the magnificent tapestry of existence, already woven into the fabric of the universe. And as you rest here, breathing slowly, letting your body sink deeper into comfort, let me tell you more about the moon's gentle mysteries, more stories that have unfolded over billions of years in that silver world above us. You know, the moon's surface is covered with tiny glass beads, millions upon millions of them, scattered across the regolith like seeds in a field. These beads formed in the most dramatic way imaginable. When meteorites slammed into the lunar surface with tremendous force, the impact melted the rock instantly, vaporizing it, sending droplets of molten stone flying through the vacuum. These droplets cooled as they arced through space, solidifying into perfect little spheres of glass before falling back to the surface. Some are clear, some are coloured, green, orange, amber, brown, depending on what minerals they contain. The Apollo astronauts scooped up handfuls of lunar soil and found it glittering with these tiny treasures, each one a frozen moment of violence turned into something beautiful. Imagine running your fingers through lunar soil, if you could, if you weren't wearing thick gloves. You'd feel these glass beads rolling between your fingers, smooth and round, mixed with the sharp, jagged fragments of broken rock. Each handful of moon dust contains thousands of these beads, each one with its own story of impact and creation. Some of them are billions of years old, formed when the moon was young and the solar system was still chaotic with debris. Others are relatively recent, only millions of years old, created by impacts that happened long after life began on Earth, but long before humans appeared. There's something meditative about thinking of these beads, isn't there? Each one perfect in its own way, shaped by heat and physics and chance. They've been sitting there on the moon's surface for eons, untouched, unchanged, waiting. Some of them have been disturbed by later impacts, buried and uncovered again over the ages. Others have sat in the same spot since they first fell, patient witnesses to the passage of time. The moon's craters have names, did you know? Thousands of them, named after scientists, philosophers, astronomers and explorers. There's a crater named Plato after the ancient Greek philosopher. There's one named Copernicus, after the astronomer who figured out that Earth orbits the Sun, not the other way around. There's Tycho, which I mentioned earlier, named after Tycho Brahe, the Danish astronomer who made incredibly precise observations of the planets before telescopes were invented. His measurements were so accurate that they allowed Kepler to discover the laws of planetary motion. Each of these craters is a memorial, in a way, to someone who contributed to human knowledge, who looked up at the sky and tried to understand what they were seeing. These people lived centuries ago, in some cases thousands of years ago, but their names are preserved on the moon, carved into the landscape by ancient impacts. Long after their civilizations have crumbled to dust, long after the languages they spoke have been forgotten, their names will still be there, on the moon, marking the places where cosmic violence created lasting beauty. There's a certain poetry to that, don't you think? That the moon, so often associated with change and cycles and the passage of time, also serves as a permanent record, a memorial that will last longer than any monument we could build on Earth. Wind and rain will eventually wear down the pyramids, the great cathedrals, the modern skyscrapers, but the craters on the moon will remain sharp and clear for billions of years to come. Let's talk about the moon's far side again, that hemisphere we never see from Earth, because there's something deeply mysterious about it. For all of human history, Until just a few decades ago, no one knew what the far side of the moon looked like. People could only imagine. Some thought it might be perfectly smooth, others thought it might be even more cratered than the near side. Some wild speculation suggested it might be hollow, or inhabited, or completely different from the side we know. When the Soviet Luna 3 spacecraft finally photographed the far side in 1959, what it revealed was surprising. The far side looked different from the near side, much more heavily cratered, with almost none of those smooth, dark maria that are so prominent on the side we see. Scientists still aren't entirely sure why there's such a difference. The leading theory is that the crust is thicker on the far side, so when those ancient impacts created huge basins, lava couldn't break through as easily to fill them in. But why is the crust thicker on the far side? That's still being debated. It might have to do with how the moon formed, or with Earth's gravity affecting the moon's early development, or with some other factor we haven't fully understood yet. The far side has one of the largest impact structures in the entire solar system, the South Pole Aitken Basin. It's enormous, stretching across nearly a quarter of the moon's circumference, about 2,500 kilometers wide and up to 8 kilometers deep in places. The impact that created this basin was cataclysmic, probably occurring very early in the moon's history, perhaps 4 billion years ago. The asteroid or comet that struck must have been huge, perhaps 100 kilometers across, traveling at tens of kilometers per second. When it hit, it excavated material from deep within the moon's crust, possibly even exposing material from the mantle, the layer beneath the crust. This is exciting for scientists because it gives us a window into the moon's interior, a chance to study rocks that formed deep underground and were brought to the surface by the impact. Future missions to the South Pole Aitken Basin might tell us things about the moon's composition and history that we couldn't learn any other way. It's like the impact created a natural drill hole, punching through the crust to reveal what's beneath. Standing on the rim of the South Pole Aitken Basin, looking out across that vast expanse, you'd be looking at one of the solar system's great wounds, a scar from the violent early days, when worlds were still forming and collisions were common. But you'd also be looking at something beautiful, a landscape sculpted by forces so powerful they're hard to comprehend, now frozen in time, silent and still. The moon experiences something called libration, which means it appears to rock slightly back and forth and nod up and down as seen from Earth. Even though the moon is tidally locked and always keeps the same face toward us, libration allows us to peek around the edges and see a bit more than exactly half. Over time, we can see about 59% of the moon's surface from Earth, though never all at once. This libration happens because the moon's orbit isn't perfectly circular, and its axis is slightly tilted, so from our perspective it seems to wobble a bit. Ancient astronomers noticed this wobbling and tried to figure out what it meant. Some thought it was evidence that the moon was alive, breathing or dancing. Now we understand it as a simple consequence of orbital mechanics. But there's still something charming about the idea of the moon dancing, isn't there? Moving to rhythms set by gravity and geometry, a dance that's been going on for billions of years and will continue for billions more. If you watch the moon carefully over many years, you'll notice that the exact pattern of where it rises and sets changes in a complex cycle that takes about 18.6 years to complete. This is called the lunar standstill cycle, and it happens because the moon's orbital plane slowly precesses, tilting back and forth relative to Earth's equator. At one extreme, the moon can rise and set quite far to the north and south. At the other extreme, its rising and setting points are closer to due east and west. Ancient peoples noticed this cycle and incorporated it into their monuments and calendars. Some stone circles and megalithic structures are aligned to the most extreme, rising and setting points of the moon, marking the limits of its wandering across the sky. These ancient astronomers didn't have telescopes or computers or mathematical models of orbital mechanics, but they watched the sky patiently, night after night, year after year, generation after generation, and they noticed patterns. They saw that the moon's path changed in predictable ways. They couldn't explain why, but they could track it, and that was enough. It gave them a sense of order in the universe, a feeling that the cosmos followed rules, that there was structure and pattern to the movements of celestial bodies. We have the same sky they did, you know. The moon you see tonight is the same moon that shone on ancient Egypt, on the builders of Stonehenge, on the first humans who walked out of Africa tens of thousands of years ago. It's the same moon that lit the way for dinosaurs 100 million years ago, though it was closer then and appeared larger in the sky. It's the same moon that formed from that catastrophic collision 4.5 billion years ago, cooling and solidifying and being battered by impacts until it became the world we see today. When you think about it that way, the moon is a connection to the deep past, a physical link to times and events so remote they're almost unimaginable. The atoms that make up the moon were present at the beginning of the solar system. Some of them might have come from the molecular cloud that collapsed to form the sun and planets. Some might be even older, remnants of previous generations of stars that lived and died before our sun was born. Everything is recycled in the universe. Stars forge heavy elements in their cores, then scatter them into space when they die. Those atoms drift through the galaxy until they're pulled into a new cloud, which collapses to form new stars and planets. Some of the atoms in your body were made in stars that exploded billions of years ago. Some of the atoms in the moon came from that same process. We're all made of the same stuff. The moon and you and the earth and the stars, all connected by this great cycle of creation and destruction and recreation. Let me tell you about the moon's influence on Earth's day length. I mentioned earlier that the moon is slowly moving away from us, and that Earth's rotation is gradually slowing down. These two effects are connected. Earth's rotation creates a bulge in the oceans, the tidal bulge I mentioned before. But Earth is spinning faster than the moon is orbiting, so this bulge doesn't point exactly at the moon. It's carried slightly ahead by Earth's rotation. This offset bulge pulls on the moon gravitationally, speeding up the moon's orbit and causing it to spiral outward. Meanwhile, the moon pulls back on the bulge, creating a drag on Earth's rotation and slowing it down. This process has been going on since the moon formed. 4 billion years ago, a day on Earth was only about 5 hours long. The moon was much closer, maybe just 25,000 kilometers away, and it appeared enormous in the sky. The tides were hundreds of meters high, great waves, sweeping around the planet every few hours. There was no life on land yet, just barren rock and endless ocean, and these massive tides crashed against the primordial shores in a rhythm that no longer exists. Over billions of years, Earth's rotation slowed and the moon drifted away. By the time the first complex life evolved in the oceans, about 600 million years ago, a day was about 21 or 22 hours long. When the dinosaurs walked the Earth, a day was perhaps 23 hours long. Now it's 24 hours, and it's getting longer at a rate of about 1.7 milliseconds per century. That doesn't sound like much, and it isn't. You'll never notice the days getting longer in your lifetime. But over millions of years it adds up. In the far future, if nothing else intervenes, Earth's rotation will slow to the point where a day is as long as a month, both lasting about 47 of our current days. At that point, Earth will be tidally locked to the moon, just as the moon is now tidally locked to Earth. The same hemisphere of Earth will always face the moon, and the moon will hang motionless in the sky for people on that hemisphere, never rising or setting. People on the other hemisphere will never see the moon at all. It will always be below the horizon for them, a distant companion they can never see, but whose gravitational influence they still feel. But that won't happen for billions of years, if it happens at all. Long before Earth becomes tidally locked to the moon, the sun will have swollen into a red giant and possibly engulfed both Earth and moon in its outer atmosphere. So this stable, tidally locked configuration is more of a mathematical curiosity than a real prediction of the future. Still, it's interesting to think about. A world where the moon never moves in the sky, where half the planet is in eternal view of the moon and half never sees it. A world where the day and the month are the same length, where the sun rises and sets just once a month, where seasons last for years. It would be a strange world, very different from the Earth we know, but in a way, it would be peaceful too, don't you think? That long, slow rotation, the stately progression of the sun across the sky, the moon hanging eternally in the same spot. Time would feel different. Rhythms would be different. Life, if any remained, would have adapted to these new cycles, and they would seem as natural as our 24-hour day seems to us now. The moon has been the subject of so much art and music over the centuries. Composers have written moonlight sonatas. Painters have captured moonlit landscapes in oils and watercolors. Poets have written countless verses about the moon's beauty, its mystery, its constancy. The moon appears in fairy tales and folk songs, in ancient myths and modern movies. It's a symbol that transcends cultures, that means something to everyone. In Japanese culture, moon viewing, called tsukimi, is a traditional autumn activity. People gather to observe the full moon, often the harvest moon, and appreciate its beauty. They might compose poetry, drink sake, eat special rice dumplings called tsukimi dango. It's a moment of aesthetic appreciation, of connecting with nature and with the changing seasons. In Islamic tradition, the new moon marks the beginning of each month, and the sighting of the new moon crescent is particularly important for determining the start of Ramadan and other significant dates. People look to the western sky just after sunset, searching for that first slender crescent that signals a new month has begun. In many Native American traditions, each full moon has a name and significance, as I mentioned earlier. These names help connect people to the natural cycles of the year, to the rhythms of planting and harvesting, hunting and gathering. The moon is woven into human culture in countless ways, some obvious and some subtle. We use lunar calendars, lunar months, we talk about mooning over someone, meaning to yearn for them. We say someone is over the moon when they're extremely happy. A honeymoon is the period after a wedding, perhaps named after the full moon, or perhaps after mead, the honey-based drink traditionally consumed at weddings. But the moon is there in the word regardless. Even our word lunacy comes from the moon, from the old belief that the full moon could make people mad. We know now that this isn't true, that there's no correlation between the moon's phases and mental health episodes, but the word persists. Language carries these old ideas forward, preserving them even after we've stopped believing in them. The moon is part of our collective consciousness, part of how we understand time and change and beauty. It's been there in the background of every human story, every triumph and tragedy, every moment of joy and sorrow. Lovers have met under the moon, soldiers have fought by moonlight, children have gazed at the moon and wondered. The moon has witnessed all of human history and doesn't judge, doesn't care, just continues its ancient dance through space. There's comfort in that, I think. The moon's indifference is not cruel but liberating. It reminds us that we're not the center of the universe, that there are forces and rhythms and realities beyond our control, and that's okay. We don't have to control everything. We can just exist, just be, just appreciate the beauty of the moon without needing to own it or change it or make it mean something it doesn't mean. The moon is just the moon, a rocky satellite tidally locked to Earth, slowly drifting away, reflecting the sun's light. That's all it is, objectively. But subjectively, it's so much more. It's inspiration and mystery, romance and wonder, a companion in the night sky, a reminder of both how far we've come and how far we have yet to go. As you continue to relax here, feeling your body becoming heavier and more comfortable, your mind becoming quieter and calmer, let the moon's presence soothe you. Even if you can't see it right now, even if it's daylight or cloudy, the moon is there. It's always there, following its orbit with mathematical precision, utterly reliable. In about 600 million years, the moon will have drifted far enough away that it will no longer be able to create total solar eclipses. That's a long time from now, longer than the entire history of complex life on Earth. But eventually, that window will close, and the spectacular sight of a total solar eclipse, the sun's corona streaming out around the darkened disk of the moon, will no longer be possible from Earth. By then, who knows what will have happened? Humanity might have spread to other star systems, or we might be long extinct. Earth itself might be very different, with different continents, different climates, perhaps different forms of life that evolved after us. But the moon will still be there, orbiting Earth, reflecting sunlight, pulling on the oceans. The moon is patient. It doesn't worry about the future or regret the past. It just continues, moment by moment, following the path that gravity sets for it. You can be like the moon in that way as you drift towards sleep. You don't need to worry about tomorrow or replay yesterday. You can just be here, now, in this moment, comfortable and safe, letting time pass without resistance. The moon teaches us about cycles, about how things change and yet remain the same. The moon waxes and wanes, but it's always the same moon. Your life has cycles too, ups and downs, times of fullness and times of emptiness, and that's natural. That's how things work. You don't need to fight against it. You can flow with it, the way the moon flows through its phases, trusting that after the new moon comes the crescent, after the crescent comes the quarter, after the quarter comes the full moon, and then the cycle begins again. There's a word in Japanese, mono no aware, which roughly translates to the pathos of things or a sensitivity to ephemera. It's an awareness of the transience of all things and a gentle sadness at their passing, coupled with an appreciation of their beauty because of that transience. Cherry blossoms are beautiful, partly because they bloom for such a short time. The full moon is special partly because it only lasts one night before beginning to wane. Everything is temporary, everything changes, and that's what makes it precious. The moon reminds us of this with its changing phases, its slow drift away from Earth, its ancient surface that still bears the scars of long ago impacts. Nothing lasts forever, and that's okay. That's how it should be. We can appreciate things while they're here, while we're here, without grasping or clinging. Imagine the moon now, hanging in space, silent and luminous. Imagine its surface, grey and dusty, covered with craters large and small. Imagine the footprints left by the astronauts, still there after more than 50 years, undisturbed. Imagine the Earth rising over the lunar horizon, blue and beautiful, the only colour in a monochrome landscape. And imagine yourself, small and comfortable, lying here on Earth, under blankets, breathing slowly, feeling your body relax more and more with each breath. You're on a planet that's orbiting a star, and that star is moving through a galaxy, and that galaxy is moving through the universe. Everything is in motion, everything is connected, everything is part of the same grand cosmic dance. But right now, you can be still, you can rest, you can let go of effort and just exist, just be. The universe will continue without your effort. The moon will orbit Earth, Earth will orbit the sun will move through space, and none of it requires anything from you. So rest now. Let the moon watch over you as it has watched over countless sleepers before you. Let its ancient light bless you with peace and calm. Let yourself drift, like the moon drifting through space, following your own orbit into sleep and dreams. The moon is patient, and so can you be. The moon is constant, and so can you be. The moon is beautiful, and so are you. Rest now, my friend. Rest deeply. Let the moon carry you gently into sleep, into the peaceful darkness where dreams are made. Good night. Sleep well. The moon is there, watching over you, as it always has been, as it always will be. You're safe. You're held. You're part of something larger, something ancient and beautiful and eternal. Sleep now.